Sometimes the biggest breakthroughs happen when you just stop and ask a simple question. What if what we think we know is just plain wrong? Today, we're going to dig into this really fascinating story from over 30 years ago. It's about an oil company, a government regulator, and how they actually teamed up to solve a huge environmental puzzle. And it all starts at a massive oil refinery in Yorktown, Virginia.
All right, so let's go back in time to the late 1980s. You're looking at the Amoco Oil Refinery in Yorktown. Now, this place was an absolute beast, a super complex facility processing more than 50,000 barrels of crude oil every single day. And like any industrial site, it was producing pollution. But here's the kicker. Nobody, not the company, not the regulators, nobody really knew how much or even where it was all coming from.
And that's the core of the problem, right? How do you fix something when you can't even see it clearly? The company had its own estimates, the government had theirs, but they both kind of knew the data was shaky. It was like they were trying to solve a massive puzzle, but half the pieces were missing. So how do you make things better when you can't even agree on where you're starting from?
Well, instead of just butting heads and getting stuck, they tried something that was, for the time, pretty radical. They decided to actually work together.
And that's how the Yorktown project was born. Now, this wasn't some court order or a new regulation being forced on them. It was a totally voluntary, collaborative study between Amoco and the U.S. Environmental Protection Agency. And the goal, while it sounds simple, was incredibly ambitious. Let's get a real, data-driven picture of all the pollution coming out of this place. Air, water, ground, you name it, and then figure out the smartest ways to actually reduce it.
So they laid out this really methodical 5-step game plan. First things first, they had to measure everything and build a real inventory of what was going on. Step 2, brainstorm all the possible ways to reduce it. Then, they'd rank those options to see which ones gave the most bang for the buck. Fourth, they'd look for any old rules that were maybe getting in the way of common sense. And finally, and this is so important, they wanted to make sure everyone involved actually learned from the process.
That first step, the inventory, was really the key to the whole thing. They had to go from these blurry, out-of-focus estimates to a crystal-clear, high-definition picture of the problem.
I mean, this quote from the project's own summary really says it all. They basically admitted that the old way of doing things just wasn't cutting it anymore. The standard formulas and government guesstimates, they couldn't capture what was really happening at this one specific facility. If they wanted real answers, they were going to have to get real data.
And they didn't mess around. They went all in, taking almost 1,000 environmental samples of everything you can imagine. You can see here, the huge majority were air samples, but they were also testing groundwater, wastewater, soil, solid waste, the whole shebang. It was a massive, super expensive job, but it was the only way they were going to get to the truth. Okay, so they collected all this data. What did it actually tell them? Well, this is where the story takes a huge turn, because what they found was not at all what anyone was expecting.
The first big question on everyone's mind had to be, what about those official numbers? The ones submitted to the government's Toxic Release Inventory, the TRI. Were those numbers even in the right ballpark?
Not even close. The official report for 1989 said the refinery was releasing about 371 tons of certain chemicals a year. But when the project team did their own direct measurements, they found the real number was 893 tons a year. That's more than double what was on the books. So right off the bat, they realized the problem was more than twice as big as the official data said.
Well, that discovery obviously leads to the next big question. If the total was so wrong, were their assumptions about the sources of that pollution also completely off?
Oh, absolutely. This right here shows you just how wrong they were. On the left, that's what the standard engineering formulas predicted. Everyone thought this one piece of equipment, the API separator, was this gigantic source of air pollution. But look at the right. That's what they actually measured. Its contribution was tiny. They had overestimated it by more than 20 times. They were literally pointing all their resources at the wrong culprit.
So, if it wasn't the separator, what were the real bad guys? This chart of what we call volatile organic compounds, or VOCs, is just stunning. The biggest source by a country mile was something called blowdown stacks, a part of the refining process that nobody had even really considered a major polluter before. That, plus small leaks from valves and pipes and emissions from loading barges, these things that were flying under the radar were actually causing most of the problem.
And this brought them to a third really critical truth. The traditional way of regulating, what people call command and control, was basically the government telling a facility, you must install this specific piece of equipment, or you have to fix that specific process.
But if those commands are based on the wrong assumptions, you could force a company to spend millions of dollars fixing the wrong problems.
This aha moment changed everything. Because now, armed with accurate data, the team could find fixes that were not just a little better, but way more effective and dramatically cheaper.
So the team compared two different paths forward. Path A was the standard regulatory approach, just doing what existing and upcoming rules required. Path B was a totally customized approach, using their new data to pick the absolute most impactful fixes no matter what the old rulebook said.
So if they had followed the standard regulatory path, it would have cost them an estimated $2,400 for every single ton of pollution they removed.
But the new data-driven approach, the one that focused on the real sources like the barge loading and those blowdown stacks, it cost only $510 per ton. That's not just a little better. That is a massive, massive difference in efficiency.
And here it is, the bottom line. The project figured out they could get pretty much the same environmental result, a 95% reduction for about a quarter of the cost. Just think about that for a second. The same cleanup for 75% less money. That is the power of having good data. So, what's the big takeaway from this 30-year-old study? Well, it turns out the lessons are maybe even more relevant today than they were back then.
The project's final report basically laid out a blueprint for a smarter way to protect the environment. It said, let's focus on cost-effective results, not just ticking regulatory boxes. Let's invest in better data so we can make smarter choices. We should create incentives for companies to do these kinds of deep dives. And most importantly, we need more of these public-private partnerships, working together to solve problems.
But when you read the report, you realize the real secret sauce wasn't technical. It was human. The key was trust. Both sides agreed from day one to let the data lead, even if it led them to some uncomfortable places. They made a pact to put the facts ahead of their own organizational pride, and that single decision made all the difference in the world.
And that really just leaves us with one final thought. The Yorktown project proved, beyond a doubt, that when you swap out assumptions for real data and you replace fighting with collaboration, you get better environmental results for way less money. It's a win-win. So the question we have to ask ourselves is, in a world that is full of incredibly complex challenges, are we actually remembering to apply these simple, powerful lessons today?